Hello students, welcome once again. We have the Taylor series application over here. Now, determine the Taylor series about s equal to 0 for the integral of e power x minus 1 then divided by e dx. Alright, so we have the integral of e power x then divided by e. So first of all, what we're going to do is that we're going to represent let's take we are taking only this part, leaving the integral part. We are going to represent this in a Taylor series form, then after which we can now integrate. Now, representing that in a Taylor series form, I'll take let's say f of x being equal to e to the power x. So f of x being equal to e to the power x. Now, representing this in a Taylor series form, then we are going to have this being equal to the summation that is from infinity to n equal to 0. Then we have s to the power n over n factorial. Now this is how to represent um, this function over here in terms of a Taylor series. Now if you have problem representing function in a Taylor series, I will link the video. I'll put the video link in the description, which you can check, or you check at the top the info card. You see a link to a video on how to find the Taylor series of a function. So I'm not going to do that step over here because I've done a video on that, so you can go back and check on that video, about 2 video. You can go back and check on these 2 video and see how to represent a function in a Taylor series form. So we have this being equal to that. So if this is equal to that, then we have this 0 then s to the power n over n factorial. Now writing out this sequence, or writing out the series of these, then we have when n equal to 0, then we have and we have 1 because 0 factorial is still 1, so we have the first term as 1. Then when n is equal to 1, then we have x over 1. Then when n equal to 2, then we have s squared over 2 factorial. Then we have the next one, s cubed over 3 factorial. Then it goes on and on. So we have this as our series or sequence. So now from here, what we are going to do is that we are going to write this series very well, because what I'm going to do is that now let's take n equal to 0. So we are taking the n equals to 0 term out. So let's take n equal to 0 term. So when n equal to 0, we have this n equal to 1, n equal to 2, n equal to 3. So we are taking this term out so that we are going to write the summation in terms of when n is equal to 1. So taking that term out, we have e of x being equal to, now we have the n equal to 0 term as 1. Then when n equal to 1, n equal to 2, n equal to 3, then we can write all of these terms as infinity. Then we are starting from 1, unlike this where it started from 0. We are starting from 1, then we have s to the power that the n factorial. So 1 here represent when n equal to 0, then the rest n equal to 1, n equal to 2, n equal to 3. This series here represent the Taylor series over here. Alright, so we have this. Now what we are going to do next is that we have e to the power x minus 1. So we are going to subtract each side by -1, right? So say subtract each side by 1. So we have ex minus 1. Then we can have 1 plus the summation of 0 infinity, then it's starting from 1 s to the power n over n factorial. Then we have all of this minus 1, right? So with this we can now have this as e x minus 1 being equal to, now this will cancel that, and we have summation infinity n equal to 1, then we have that and that, right? So this is what we have. Now what I'm going to do next is that we have, now from the question we have the integral of ex minus 1 over x dx, so which means that e power x minus 1, the whole of this is just that. So let's do the substitution. So the whole of this is just that. So we have summation 1 here, x power n factorial over x, then we have dx. So this is what we have. Now from here we are going to have this open as factorial here, n equal to 1, then x to the power n, then n factorial multiplied by 1 over x, then we have dx, which is the same as factorial here, n equal to 1. Now when this s goes up, it becomes n plus n minus 1, sorry, n minus 1, then we have divided by n factorial, then we have dx over here. So this is what we have. Now from here we can then go ahead and integrate now. So we integrate with respect to what? X. So integrating with respect to x, we have the whole of this n equal to 1 here, then we have, now in integration, for the power we add 1 to it, then we divide by the power, which is n minus 1 plus 1, then our n factorial. So we have integrated now plus c, right? So we have the summation of all of this equal to 1, then we have x power n all over, this one goes to 0, then we have n here, then also n that, plus c as our final answer. So thank you very much for joining me in this section, and I hope it was helpful. I'll see you in another section. Have a nice day.